Hey everybody, how's it going? So I just wanted to show you my old periodic table here. I've had it since like 2005, so that's why it looks all old and beat up. But I've held on to it because I think it's like the most useful piece of thing in chemistry that I've ever had. So I'm just going to show you here. If you look at the top, it has the groups 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 12, 13, 14, 15, 16, 17, 18. But if you look underneath there, there's also 1A, 2A, then there's a bunch of B's, and then 3A, 4A, all the way through to 8A. And I think that this is really helpful when you're trying to make a Bohr diagram. So I'm going to make a simplified version of the periodic table and show you what I mean. So here's that simplified version of the periodic table I was talking about, and it has the first 18 elements in it. Now instead of numbering the groups through from 1 to 18, we can call this one 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. And then on the side, this is period 1, period 2, and period 3. So how is this useful? Well, this actually tells us a lot about what each Bohr diagram is going to look like. So I'll show you what I mean. So let's take hydrogen, for example. So hydrogen is element number 1, and it has 1 electron. So if I make the nucleus here, and it has 1 orbit with 1 electron, it has 1 proton and 0 neutrons. So this is what hydrogen looks like. But we can actually get that information using the periodic table. So remember that the number on top of each group will tell us how many valence electrons there are. So all the ones in this one have 1, all of the elements here have 2, and then remember on the other side we talked about group 17 had 7 valence electrons, group 18 had 8 valence electrons, and it's true for all of these elements in the middle too. So these have 3, 4, 5, and 6. Now the periods, the number of the periods here on this side, they actually tell us how many shells that each electron, that each Bohr diagram will have. So hydrogen has 1 shell. The elements that are here in the second row have 2 shells. The elements here in the third row have 3 shells. Let's take a look at another example. So here's carbon. Carbon has an atomic number of 6, and it has an atomic mass of 12. So remember, the atomic number is how many protons and how many electrons there are. The atomic mass is the number of protons plus the number of neutrons. So if we look here in the periodic table, here is carbon. Carbon is in row 2, which means that it will have 2 shells in its Bohr diagram. And it is in column 4A, so it's going to have 4 valence electrons. So if we draw out the diagram, there's our nucleus. It has 6 protons. And then if we do some quick math here, 12 minus 6 is 6 neutrons. Now we can draw our 2 shells here. And we said that carbon will have 4 valence electrons. So we can draw those 4 valence electrons in, like so. And then all of our shells that are inside of that are just going to be full. So carbon has only 1 shell left to fill in, and it can hold a maximum of 2 electrons. So we can just draw those in. And that's the Bohr diagram for carbon. Let's check out one more example. Alright, so let's do an example with sulfur. Sulfur's atomic number is 16, so it'll have 16 protons and 16 electrons. And its atomic mass is 32, so we can use that to figure out the neutrons. So if we look at the periodic table here, sulfur is right here, number 16. It is in column 6, so it's going to have 6 valence electrons, and it's in period 3, so it's going to have 3 shells in its Bohr diagram. So if I draw out the nucleus here, it has 16 protons, and then here I'm just going to do some quick math. 32 minus 16 means that it has 16 neutrons as well. So I'm going to write that in here. Now remember, sulfur is in period 3, so it has 3 shells. So 1, 2, and 3. Looks sort of like that. And it is in column 6, right there. So it's going to have 6 valence electrons. So 1, 2, 3, 4. And remember, it's good to group your electrons in groups of 2 when you can. So 1, 2, 3, 4, 5, and 6 valence electrons. Now we can just fill in the rest of the shells. So shell 1 can have a maximum of 2 electrons, and shell 2 holds 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. So is our diagram correct? Well, do we have 16 electrons? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And sulfur's atomic number is 16. So I hope that this helps a little bit with drawing Bohr diagrams. If you have any other questions, feel free to ask, let me know. But until next time, have a good one.